Let's solve this together, okay? It says 1 over 3 all raised to power x equals to x over 4. How do we solve this? First thing we can do here is to say that we have 1 raised to power x divided by 3 raised to power x to be equal to x plus 4, okay? Now, from here we now have 1 raised to power x is 1, so we have 1 over 3 raised to the power of x to be equal to x plus 4, okay? Moving on from here, we can now say that let's multiply both sides by 3 raised to power x, okay? So multiply this side by 3 raised to power x and multiply this side by 3 raised to power x. Remember that this is in brackets, okay? Now 3 raised to power x raised to 3 raised to power x. So we have 1 here to be equal to 3 raised to power x multiplied by what? X plus 4, okay? So you can now say that x plus 4 into 3 raised to the power of x is equal to 1. Alright. At this point, we're going to try to use the formula known as the Lambert-Zoré formula, okay, to solve this. Now, for the Lambert-Zoré formula, it is given when we have x in the base and x as a power. As you can see, x is an exponent here and x is in the base. So you're going to use the Lambert-Zoré formula to make it work easier for yourself. The Lambert-Zoré formula states that when we have w, which is the product log, okay, of a number multiplied by e raised to power that same number, okay, it's equal to that number. Alright, so just if we have something in this format, so if, say, for example, we have for this equation now that is x as a variable, we would have w of brackets x e to the power of x to be equal to x. Alright, so this is what the Lambert-Zoré formula states. Now it means that we have to get this in the form where it looks just like this in order to be able to apply this w in this question. Alright, that's it. Now moving on from here, we can say that recall when we have that a raised to power m is multiplied by what? A raised to power n is equal to a raised to power m n. I recall that I required to make this and this equal just for now, alright? Now this is x raised to power 4, we require to put x raised to power 4 here. If you make this x raised to power 4, it means that we're multiplying by 3 raised to power 4, okay? Let's now multiply both sides by 3 raised to power 4. So we have 3 raised to power 4 multiplying this side, so we have x plus 4. Alright, multiplied by 3 raised to power 4 multiplied by 3 raised to power x is equal to, we do the same thing here, 3 raised to power 4 times 1, which is 3 raised to power 4. Okay, now from here you can now see that when we have 3 raised to power 4 and this, we do the same thing here. So this is plus n. So we are doing the same thing here, we're going to have x plus 4 multiplied by 3 raised to power 4 plus x, okay? And this is equal to 3 raised to power 4. Alright, now moving on from here, you can say now that we have at least this looking alike, okay? So this is x plus 1, x plus 4 here. Now, but recall that we want to put in e and not 3. So we're going to say something. We're going to say that when we have logarithm to base e of say 3, okay? So this 3 here, it's equal to y. Alright? Now for logarithm, recall that you have to do e raised to power y, alright? So you say e raised to power y is equal to 3. But what's our y? Our y is logarithm of e to the power, logarithm in base e of 3. Now logarithm in base e of 3 is something as natural log, that's ln of 3, right? So this is the same as ln of 3. Now we replace y with ln of 3, so we have e raised to power ln of 3 is equal to 3, alright? Simple. Now let's apply this here. So we're going to have what? That instead of writing 3 here, we'll have x plus 4 multiplied by what? E raised to power what? Ln of 3, okay, which is also equal to 3 from what we've said. Now this is raised to the power of what? This is raised to the power of x plus 4, 4 plus x is the same thing. And this is equal to 3 to the power of 4, okay. Now from here, we can now say that when you have a raised to power m raised to the power of n, it's equal to a raised to power m times n, okay? So when you have something like this, you take the product of the powers. Now we apply this same law here. Okay, so if I apply the same law here, so applying the same law here, we're going to have that this becomes x plus 4. Okay, now we now have into, we have e raised to power what? Ln of what? Ln of 3 multiplied by x plus 4. Okay, and this is equal to 3 raised to power 4. Now we say something here. Okay, we can do something here. Now we can say that we multiply both sides by ln of 3, just so that we remember that we said we will have a number e raised to power that same number. Okay, now you can see that we have x plus 4 here, we have x plus 4 here. The only thing missing is ln plus ln of 3. Multiply this side by ln of 3, multiply this side by ln of 3. We're going to have a uniform thing on both sides of x. Okay, let's do that quickly. Now you can say ln of 3 into x plus 4 e raised to power what? Ln of 3 into x plus 4. Okay, will become equal to, now we now have 3 raised to power 4 is what? 81. Okay, so we can say that this is what? 81 multiplied by what? Ln of 3. Alright, multiply both sides by the same thing. Now from here we can say, let's keep this constant, but recall that when we take the w of this, it should be what? It should be this, it should be this alone. Okay, so we can say let this whole thing be equal to y. So assume that this is equal to y for now to make our solution easier later. And this is now equal to 81 is same as what? 27 multiplied by 3. Okay, now we have multiplied by ln of 3. Alright, now y now can be equal to 27 multiplied by, when you have something like this in logarithm, you can raise 3 by 3. Right, so we can say that this is 27 multiplied by ln of 3 raised to the power of 3. Now y now becomes equal to 27 is now equal to 27 multiplied by what? Ln of 27. Alright, so this is what this becomes. So just as before, we can say that 27 here could be equal to, 27 will be equal to e raised to power ln of 27. Recall from what we said before, multiplied by ln of 27. Okay, now this is equal to ln of 27 multiplied by e raised to power ln of 27. Okay, you can see we now have uniform thing on both sides of e. Now we can now say that, remember that this is equal to ln of 3 multiplied by x plus 4 multiplied by e raised to power ln of 3 multiplied by x plus 4. Okay, so this is what this is. Now we can say, let's take the w of both sides. If we take the w of both sides, we have w of this side and w of this side. Now recall that when you have w of any of these sides, it becomes equal to, when we take the w of this, so this is y, recall. Let's call this one z, so let's make our work neater. Okay, now what does this become? W of y becomes only this from our law, from the law that says that if you take the w of this, it gives us this. Okay, so we're going to have that this becomes ln of 3 into x plus 4 is equal to ln of 27. Sweet deal. Now let's divide both sides by ln of 3. Alright, so we have x plus 4 is equal to ln of 27 over ln of 3. Alright, now you have that our x plus 4 becomes equal to, now ln of 27, let's use it in a different place. ln of 27 is same as saying ln of 3 raised to power 3. Alright, now this is equal to 3 multiplied by ln of 3. Okay, from laws of indices. Now apply this here, so we have 3 multiplied by ln of 3 divided by ln of 3. ln of 3 strikes ln of 3, so we have 3. So we have that our x plus 4 is equal to 3. Okay, finally we now have that our x is equal to 3 minus 4, which is negative 1. Okay, so this becomes the final answer to this question. Thanks for watching. If you made it to the end, please like, comment and subscribe. I'll see you guys in my next video.